Weather freaks, welcome to another fun-filled, action-packed, and special edition of This Week in Weather for this Friday, November 17th. Look, just 6 days before Thanksgiving. We got so much weather to talk about. Before we get to that, let me remind everybody that I am the captain of chaos, the colonel of confusion, the commander of catastrophe. Let's talk about this week in weather. And items here we're going to talk about. This is going to be a long report. I'll try and keep it moving, but there's a lot of information here. First, we have important information about the El Nino. We have a major eastern U.S. low, a type of storm, which the old timers called a tree stripper. A tree stripper storm, because what it does is it strips all the leaves off the trees with the heavy rain and wind. You often get these types of big storms in the Midwest, the East Coast, during November, and it pulls all the leaves off, and it usually announces the beginning of winter, or at least a winter pattern. And also, with this storm, we have the risk of interior northeast snowfall, and then major snow, lake effect snow as well. And then after the storm, winter arrives to last fall, at least a week, last week of November. And then we'll talk about the threat of a super El Nino being off the table. So we'll start out here by taking a look at the latest ENSO conditions. And you can see we're not seeing a lot of movement in any of these areas. This is Australia as of November 12th, and this is CPC. Notice that ENSO 1.2 off of South America has actually dropped quite a bit recently, but the rest of the areas are pretty close to normal. And the latest projections from the CFS, now this is the one from November 3rd, and this here on the left is November 16th. They're very similar. As you can see, there's the 2 degrees isotherm right there. So if the area in 3.4 in this area goes above 2.0 centigrade, then you get a super El Nino. And super El Ninos have a tendency of overwhelming the winter in the central and eastern U.S. with a lot of warm conditions and very little snowfall, except for one big storm. That's what happens when you get a super El Nino. So that's the difference between super and a strong one. Currently, we are in strong El Nino, but we're not at super. So the CFS, both of these ones keep it, you can see, very consistent here. Keep it around 1.7, 1.8, and they drop it. And that's where we are right now, as you can see. 1.84 on the Australians, 1.85 on CPC. Now, the latest global model projections here from the NME, you can see here, this is from November, and this is October. And the brown line here shows you the 2 degrees centigrade isotherm for this is 3.4 region, right? So you can see many of the models are getting up to that level. And the dashed black line is the mean of all 6 different models. Now again, you can see the CFS, the European, the French model, the British model, the German, the Canadian. But in the new run here in November, notice all of them are staying below the 2 degrees centigrade line. Very, very strong agreement. Reaches its peak in December and then starts dropping in January, big time. In fact, if we look at the latest trend, the 15-day me trend here, and this is from cyclonic weather, you can see this is this is the CFS here. This is region 3.4, and you can see the bottom here around October 15th or so, 1.56, and the top about 1.76, and then about 2/10 of a degree right in this range. This is a very small range. This is 1.72, 1.7, 1.68, 1.66, so on and so forth. So this is a very small range here, but you can see it's definitely stabilized in the last 30 days in this general area. Now that's 3.4. The other region off the coast of South America, let me bring this photo here, you can see, it's also, look at this, it's been a steady downcline from about 2.75 now down to about 2.3 over the last 45 days since October 1. Again, so definitely it has plateaued in that area. So we may be approaching a peak here with the El Nino. That's my point. And if you look at the latest value, this is the sea surface temperature map. This is as of, I should say, November 16th. Let me change that for you. And you can see a lot of features here. Now, this is the Indian Ocean dipole, the warm Indian Ocean, that's area A. Area B is the El Nino. Area C is the PMM, okay? This is a negative PMM right here, area C. Okay, this is interfering, we've talked about this before, with the El Nino. Okay, this pool of cold water is blocking the El Nino from impacting the atmosphere like it normally should. And we can see that in a lot of different ways. And then, of course, there's also in the Atlantic, and this is pretty much come to an end now. There was a positive AMM, which helped the hurricane season. It's also interfering with the rainfall in Brazil. They're having a big drought in Brazil. All right. The other factor here is the MEI. I talked about this before. Now, over the past 2 or 3 weeks, we've had a lot of meteorologists argue on social media, Twitter, what have you, that the MEI, which is behind where it should be, is going to catch up in November, December. Well, the value came out for November and actually dropped. It was 0.6, it dropped to 0.3. So this is the Super El Nino 82-83 here. This is the Super El Nino of 97-98, 2015-16. These are strong El Ninos. As you can see, the gray line here is way under where it should be. Way under where it should be, not even close. So it's underperforming. There's no doubt about that. And you can compare it to other El Ninos. I've posted this before, but this is updated now. This is one in the upper left. These are moderate El Ninos. And these were all good winters on the eastern United States for the most part, except for 94-95. But you can see 2009-10, 86-87, 2002-2003. Those are good winters. And you can see that the black line matches those very nicely. And it's also in very good agreement with weak El Ninos. So this is clearly not acting like a normal El Nino. That's the point. And you can see why this is the PMM. So we are in the negative phase right here, the cold phase. This is a schematic of what it typically looks like. This is how you learn about it when you're reading about it on journals and in textbooks. So this is the PMM, a warm phase here. This is Baja, California. It goes south of Hawaii towards the equator. And this is the same thing, Baja, south of Hawaii towards the equator. This would be El Nino. So this cold water is interfering with the El Nino. That's what it does. It's long known, long proven. Now, when you have the PMM and you have La Nina like we had the last 2 or 3 years, and this is cold water, then you have an amazing amount of cold water in the Eastern Pacific, and that always produces a huge trough on the West Coast, which is what they had last year, all the huge atmospheric rivers, the record snowfall, and that leads to a big ridge on the eastern United States with no cold and no snow, and that's exactly what we saw from Boston over towards central Illinois and down towards Tennessee, North Carolina, Virginia. No snow anywhere. We all saw that. Okay. The other feature here, this is from Ben Noll, a great meteorologist. He used to live in New York, Hudson Valley. He's now in New Zealand. And you can get this information on his website if you want to look at it. But this is important because this is the 200 velocity potential anomalies, VPAs, energy in the atmosphere. I don't want to get too technical here, but that's what this is. And this is for the June through October 1982 Super El Nino. This was a Super El Nino here. Look how strong the rising motion, green is rising motion. Remember, rising motion means convection, it means thunderstorms, it means energy going to the atmosphere, it means low pressure. Okay? And that was 82-83 in the Eastern Pacific, right? Super El Nino. This is 89, this is 97-98, okay? The beginning of that El Nino. Look at the dark green here. Super El Nino, right? This is 2015-16. Look at the dark green here. Super El Nino. Now look at 2023. Where's the dark green? It's not there. It's not there. Okay? If this is right, we only have another month or so because by December, January, the El Nino is going to reach its peak. All the models agree about that. This is telling me we are not seeing Super El Nino. It's off the table as far as I'm concerned. It's not going to happen. Okay, and even if technically the sea surface temperatures do reach that, the atmosphere certainly is not responding to it like a strong or Super El Nino. It just isn't. So there you go. And one of the reasons we know this El Nino is screwed up, besides the hurricane season, besides the drought in the Midwest, okay, which is still there, by the way, we now have a drought in the deep South. When do you have a drought in El Nino in the autumn and winter in the southern states? That is the defining definition of El Nino. Strong southern jet, a lot of rain in the southern states. And here we have the drought monitor map for November 7th, and it's dry everywhere. Again, not a normal El Nino, folks. I'm trying to use real-time experiences to point out the discrepancies. And this is the southeast states. We all know here in Virginia, we're being hit with it. Western Maryland, being hit with it. Western North Carolina, Alabama, Tennessee. It was a very dry condition. Not as bad in eastern Virginia, eastern North Carolina, eastern Maryland, but very pronounced dryness here. Getting a lot of complaints about it, a lot of questions about the drought. It's bad. We have some good news on the way. We'll get to that in a second. This is the last 30 days. Look at the rainfall. Since October 13th, November 11th. This is actual rainfall percentages of normal. So you see the red color here? That's a quarter of an inch to half inch in the Shenandoah Valley. Are you kidding me? Are you kidding me? And then under an inch from the Pennsylvania-Maryland border all the way down to Georgia, with pockets, again, in the Blue Ridge and western North Carolina, even under that. Notice that Ohio is fine, western Pennsylvania, New York State, New England. They've got buckets of rain up in here. They're doing great. Now, not buckets, relatively speaking. Of course, it has been dry there. As you can see, percentages of normal, everybody up and down the East Coast has been dry. From New England, where it's only about 70, 50% of normal, though it has been drier than normal there, and then extremely dry in Virginia and the Carolinas, Tennessee, northern Georgia, extremely dry, as you can see. Okay. And that's affecting the stream levels. This is a big deal for my agricultural friends. This is a big deal. Now, fortunately, the drought began after most of the growing season in the mid-Atlantic and the Tennessee Valley areas. So this is really like a harvest drought. But the river levels, the well levels are getting very, very low. Look at these colors here. This is here's Virginia, Maryland, Pennsylvania, Delaware, New Jersey. The dark reds are like 10% or more below, only 10% of normal. Look at that. It's amazing. And then in North Carolina, let me blow up the North Carolina one. You can see a little better. Here in North Carolina, again, the western half of North Carolina, northwest, South Carolina, really getting crushed here with the dry conditions. 10% of normal, 10 to 24% of normal rainfall. In terms of the river levels, it's just really, the river levels are being killed here. All right, let's go on to the next topic, the MJO. This is so interesting, but fascinating. Okay, here we have the Japanese model, the GFS model, and the European. Now, all the models are taking it. The black line here is where it has been, okay? So it was in the neutral circle. It's come out into phase 8. And notice the red and the blue lines, it goes in phase 8 and phase 1. There's a little loop-de-loop. Then it gets into phase 2 on the Japanese model, the GFS phase 2, and then it goes back into the neutral circle. The difference here is that the GFS goes to December 16th. You see that? And the European goes to December 14th. You see that? Okay. So they both turn it back into the neutral circle. So in other words, it's stuck in phase 8 and phase 1. It's not going anywhere. It's getting caught in this loop. Now, there's good news to that and bad news to that. So let's take a look at it. All right, here's phase 8 in November and December. So on the left-hand side, we have precipitation. On the right-hand side, we have temperatures. So if we call up our marker here, okay, so here is phase 8, November, precip. Okay, very dry on the East Coast. Well, we've seen that. That's obvious, okay? And then good rains in the Midwest and the Deep South. We're seeing that as well, okay? The last week or so, they've had tremendous rains from Texas into Alabama. Okay, along the Gulf Coast. And the temperatures, well, kind of on the, not a little below normal, the Mid-Atlantic. We've seen that. New England, and then upper Midwest, and then somewhat above normal across the Deep South. Okay, so but the same thing, phase 8, look what happens when we go from November to December. Look at the difference in temperatures. Phase 8 in December is much colder. Totally different pattern. Really cold in December. Now, the problem is it's also very dry. So that's a issue with the dryness, but it does stay cold. Now, phase 1, again, the same sort of problems exist. Okay, here's phase 1 in the top. Look how wet it is in November. And that's exactly, we're going to see that right this coming week, coming up before Thanksgiving. A massive Midwest storm. And then going up towards New England. And it's still a little dry on the I-95, but not as dry. Now the temperature is very mild along the East Coast of the Deep South. All the cold is in the Rockies and the upper plains, upper Midwest. But phase 1 in December, totally different temperatures. Look at the difference. Very, very different here. And the rainfall pattern also is about the same. Still pretty wet in the Midwest and the southern states, and a little on the dry side in the Northeast from Virginia up into Boston. Now, the question is this real? And the reason why we're asking this, of phase 8 and phase 1, going into December, is because of the MJO. Now, this is what the MJO looks like on a geographical location, all right? So here we look at the diagram, we see the different phases, phase 6, phase 7, phase 8, phase 1, phase 2, phase 3. Everybody see this? Phase 4, phase 5, okay. But if you stretch them out on the geography, it looks like this. Phase 1, 2, 3, 4, 5, 6, 7, 8. Okay. The problem is that right now in the Indian Ocean, the Indian Ocean is very, very warm. We have a thing known as the positive phase of the Indian Ocean dipole, the IOD. Positive phase, warm. You see the dark red areas? This is the Indian Ocean convection because the Indian Ocean is so bloody warm. It's developing thunderstorms along the equator, which appear on the MJO models to be phase 8 and phase 1, but they're not really a normal MJO impulse. It's kind of a false signal, and it's occurring because the Indian Ocean is very warm. So what's happening is this phase 8 and phase 1 may not be doing it. For example, in South America, phase 8 and phase 1 in November and October is really, really wet for Brazil, and they're having a crippling drought because it's not really phase 8 or phase 1. So while it looks like we get cold in December, I'm not sure if that's actually true. There's a lot of uncertainty here. That's the point I'm trying to get across. Okay. Now, the other news is that the IOD, the Indian Ocean Dipole, is going to weaken. Here we are in November. This is the peak. Look what happens in December. Starts going down January, February. So once the Indian Ocean begins the cooling off and going back to normal, this problem we're having with the MJO and here in the convection, that's going to come to an end. And the MJO begin to do normal things like it does when it goes like the one phase, phase 8, then 1, then 2, then 3, starts moving like it normally does through the different phases. But that probably won't happen until late December or January, which, by the way, is when the climate models are showing winter really beginning in the eastern U.S. Okay, let's talk about the operational weather. This is a map from November 15th, big ridge over the Midwest, the Plain States, a trough on New England, allowing some cold air to come in the last couple of days, but generally it's been pretty mild and fairly dry most of the country east of the Rockies. This upper low is going to become a problem here. What happens is this is the map on the left is November 18th. Okay, so this monster trough and this energy in California, they merge, crash into the west coast. Okay, a big ridge forms ahead of it. This is the cold front coming in tonight on the east coast with some rain. The rain's going to fall apart crossing the Appalachians. But this is the big system coming up on Tuesday, Wednesday, Thursday. So here it is on late on November 20th, early November 21. The one trough, the northern stream and the southern branch, they meet. There's a short wave here. They're going to form this huge party. And look at the ridge building up into the west coast of Alaska, pulling down the cold air. See the lines coming out of the northern areas, the North Pole down the Canadian Rockies, sending the cold air southward. So look what happens. Boom! Look at this baby. Look at that. That's November 22nd into the 23rd. That's winter. This is winter, boys and girls. That is not a game. That is not a fake. All right? And we can see the important here's a big ridge in western Canada. Look at the lines coming out of the Arctic region, straight down into the Dakotas, down into the Ohio Valley. Huge upper low in the eastern Great Lakes. Look at the block in Greenland and Labrador. Big, big storm system. Big, big system. And remains that way. This is now on the right-hand side here. This is November 24th. This is the day after Thanksgiving. And you can see here the upper low is now moved into, let me call it my marker so you can see it. Has now moved up into eastern Canada. But look at the huge ridge in western Canada, pulling down the cold air. And there's another piece of strong energy in California, Nevada, which has to be watched as well. If this was, now we don't have other features. We don't have a Greenland block here. It doesn't stay very long. We don't have a 50-50 low. We have other problems with the pattern. But, this would be a potentially winter event, maybe for the Midwest and the Ohio Valley, if this was the middle of winter. Now, let's look at the surface. Okay. This is from the morning GFS, as you can see. Okay, so there's the cold front, moderate rain coming through. All right, there's the southeast low. And the front kind of falls apart when it reaches so it's going to bring some rain to the dry areas in western Virginia, western Maryland, central Pennsylvania, western North Carolina, but not a lot. The front does fall apart. The rain kind of falls apart later on tonight, tomorrow morning. Now, for Monday, here comes the system out of the southwest. There it is, the low pressure area. There's the cold high over the Great Lakes. So the dashed black lines represent the atmosphere being cold enough to support snow. So you can see the snow line is right along the Pennsylvania-Maryland border down into north of New York City and Connecticut, the Connecticut coast at that time. Now, The GFS from this morning takes the main low up through Kentucky and then bombs it out into the Great Lakes. Look at this system. It explodes into a blizzard for the Great Lakes on Wednesday, November 22nd. This is the day before Thanksgiving. Look at the rain. This is a huge travel day. This is a disaster, folks, for people traveling. It's a real nightmare. Now, I mean, the day before Thanksgiving is the biggest travel day of the year. We all know that. But when you have heavy rain, high winds, thunderstorms, blizzard conditions in the Great Lakes with the high winds there, 50 miles an hour, okay, and heavy rain plowing up into New York City and Philly and Boston, maybe some snow changing the rain in those areas, this is a big stinking deal. And then the cold air comes. Look at the winds pulling down the cold air behind this system. This is a big deal. This is a big system. This is going to pull down all the leaves off the trees. That's why we call this a tree stripper storm. There's a tongue twister for you. A tree stripper storm, and pulls down all the leaves. It's going to be quite a deal. Then what happens afterwards? Well, this is a Wednesday night. This 977 in Lake Huron on the morning GFS. Look at this monster. Look at the high winds howling behind this thing. 50 mile an hour winds, 60 mile an hour wind gusts across the Great Lakes down into the Appalachians, western New York State. Look at the lake effect snows. Wow. And then even here, this is now Friday. Okay, you have a surface trough cutting across the Great Lakes, a tremendous amount of lake effect snow in the snow belts here, Arctic high coming down. This is a cold Thanksgiving. And the European, now that was the GFS from this morning. Okay, now the European was showing the same sort of thing. I didn't post the European, but it showed very much the same thing. So I thought it was, unnecessary to do. But the European was showing the same sort of thing. Now the 12Z GFS came out, and it's a little different. And what happens is that the main low goes off the Virginia coast. You see what it does? Remember, here the low goes up into the Great Lakes. See that? But on the 12Z run, it's totally different. Very different run. And it takes the low off the coast, off the Maryland-Delaware coast. That allows more snow in the mountains of New York State and New England. And as a result, the GFS is producing this, the 12Z run. 12Z, here Friday, you can see the snow in the Catskills, several inches. Now, are you going to have a 10-to-1 ratio here? No. And you're going to have a lot of rain. The ground temperature is going to be very warm still. So, but yeah, in the mountains here, you could get snow like this. You could get 3-4 inches of snow in the mountains easily. All right, there's the operational GFS. This is the GFS ensemble in the mountains of the Adirondacks and northern New England. It's really heavy snow up into Quebec and those areas. But, it even has a couple of inches of minor accumulation into central Pennsylvania, not far, that's to the north of Allentown and New York City. Rain, initial period of snow changes over to rain here. The GFS, here's a sequence of events. Now, I think this is wrong. I think this is BS. I do not like this at all. But this is what the GFS is doing. It actually has the precipitation beginning as a mixture of snow and sleet in northwest Virginia in the northern Shenandoah Valley on the evening of November 21. There's the cold high. You can see we're still getting a northeast wind. The cold air holds in here. You can see that. And the low moves off the coast. So the cold air kind of lingers in place over Pennsylvania and New York State. And that's why you get the snow there. And then here you can see the low. Look where the low is, way to the east. See that? Off the Virginia coast. That's not what it was showing earlier. So this is a huge change. And I think this is bullshit. And I just think it's wrong. It's not accurate. But that's what it's showing. Okay? So we'll see. Maybe it turns out to be correct. I'm not saying, but right now I'm extremely doubtful of this solution. Here's the European, and this is what I showed to mean. The European takes the low right up the Ohio Valley. It doesn't go off the Virginia coast, so all the warm air comes blasting through, drives the cold air out. You get a little bit of snow in the mountains of New York State and northern New England, northern in Vermont, New Hampshire, and that's it. It's all rain. You can see the strong southwest winds is driving the system up there. Okay. Now the European does have some snow, and I think this solution is much more viable. This is an elevation snowstorm above 1,000, 2,000 feet in the Adirondacks, not the Catskills, but the Adirondacks. Not much in Pennsylvania. I think that's correct. And then you see the mountains of Vermont, New Hampshire, northern New Hampshire and Vermont getting hammered as well. Western New York State, western Maine getting hit as well. Now in the Great Lakes, we have lake effect here, which I think that's right. Another difference here. These are the 925 temperatures. Okay, this is 2,000 feet above, or 1,500 feet above the ground. Here's the GFS. you see, this is the zero line. See, this is like the frozen ice line here. See that? Right through Pennsylvania. Okay? Right there. So the purple line, that's the zero line. So all this is cold enough, sub-zero, 1,500 feet to produce either snow or sleet. Now look at the European. That line is way the hell up on Montreal because it brings the low inland. The GFS takes it east off the coast. So, in terms of rainfall, well, pretty good rains here. The GFS has good rains in the drought areas of Virginia, West Virginia, Maryland. Not so much North Carolina, but the European does better here. The European does better with North Carolina and Virginia. Widespread 1 to 2 inch rains in those areas. Just what the doctor ordered. They need a lot more rain than this, but this is a nice start. All right. Longer term, what happens? Well, if we look at our teleconnections, let's look at the Pacific side. Okay, we have 2 teleconnections on the Pacific side of North America. The Eastern Pacific Oscillation, which is the Alaskan Ridge or Alaskan Low, and then this is the PNA, the West Coast Trough. So the EPO is very negative, which means you have a big ridge in Alaska and Western Canada pulling down the cold air. That's what you want to see. And we have, and we can see that here. Let me take a look at the map here. You can see that here. Bring this forward. Okay, you see the huge ridge right here. This is part of the positive. That's part of the negative EPO right here. All right, so that matches. That's good. And then the PNA, which right now is positive. Here, it starts going towards neutral by the time you get to end of November and early December. It's all models have it going neutral. Okay. If now, if we go to the Atlantic side, here's the NAO. It's neutral, as you can see, where it has been slightly negative. It goes generally either side of the neutral line right through December 3rd or 4th. And then the Arctic Oscillation, right now, it's slightly positive. It's kind of trending towards neutral or negative by the beginning of December. And if we look at the upper air maps, okay, here's week 2. Now look at this upper air map for November 26th. Let me bring it forward so you can see it. Look at this huge ridge here. This is classic negative EPO. Big ridge all the way up into the Arctic region. That is classic negative EPO right here. Okay, so that matches. That's good. Okay, and then, oops, let me bring this, bring it forward. There we go. And you can see there's the polar vortex. Very nice polar vortex for late November. And there's a broad trough here. See this? The broad trough here. So maybe some sort of low pressure area in this. We'll have to watch that later on in the season. And there are indications of another storm coming out of Thanksgiving weekend. And then look at here on the bottom right. This is November 30th. And this, you bring this here. This is a big deal. Big ridge on the West Coast on the European. Look at the nice trough here. Negative anomaly in the southeastern states. Some blocking in Greenland. This is a very nice winter pattern. This has all sorts of potential, So this is a really nice start to winter. I don't know if it's going to last, but it looks pretty darn good going into the first week of December, I got to tell you. Now, finally, last couple of maps here. I'll finish this up. Okay, here is the European, 192 hours out. This is the 12Z run on Friday. There's the next low, comes out of Kansas and Oklahoma, goes to the Midwest. A little bit of snow for Chicago. High pressure off the coast, giving south winds, so this is rain for the Ohio Valley, the East Coast, and then tracks up into Pennsylvania. Again, Great Lakes, northern New York State, Ontario, northern New England, snow, everybody else's rain. And then more cold air coming in behind it. And that sets up the stage for this event at day 10. Now, I don't know if this is right, but it has a huge Arctic high here. Very impressive. 1045 millibars, a lot of cold air, and some sort of low pressure area trying to develop in Texas and Oklahoma. Look at the snow breaking out in these areas. Now, again, if this was January or February, yeah, this would be a big deal. I don't know if this is right, but we'll see. Okay. By November 25, we'll be in phase, on November 27th, we should be like in phase 1 at that point, which is not great for November snow. That's not great. So I'm very skeptical about this. The GFS also has the system, but it's got it further north, and I think this is correct. the GFS is a nice system here. You can see cold Arctic high. They're getting a big snow in the plain states, the Rockies, and the low goes to the Midwest, and it drives up into the Ohio Valley. You get some snow in the Great Lakes to Chicago to Iowa. That's nice to see. Late November snowfall, and then this is all rain for the Mid-Atlantic and most of New England. And I think that solution makes sense. So I like that. I like this more than this. I like this solution more than this. All right, that's the presentation. Whew, a lot of talking there, I know. Hopefully you enjoyed this and learned something from it. This is meteorologist DT from Weather Risk. I will see you over on the Twitter page and over on the website. And don't forget on the new Threads page, on the new Twitter page, Weather Risk snowstorms.